the distance moved by a freely falling body starting from rest during the first, second, and third second of its motion are proportional to. Before we start the actual solution, see, students always come to this conclusion: half S1 is equal to half G T1 square, which is equal to first. So S1 is equal to half into G into 1 square, which is equal to half G. And then they take second, which is S2 is equal to half into G into T2 square. Therefore, that becomes S2 is equal to half into G into 2 square, which is equal to okay, let me like this half into G into 4. And then they take the ratio, and then they get the ratio as 1 is to 4 is to 9, and so on. Okay. Now, why is this wrong? I'll tell you the point. See, S at, when you say S is equal to UT plus half AT square, and when you put 2 here, what you do is, what you're trying to find out is distance traveled when time of observing the motion was 2 seconds. But when you say Sn S2, it means that it is the distance traveled in the second. Okay, so distance traveled in 2 seconds minus distance, or the distance traveled in the second. These two are different. Now, how are they different? We'll have a detailed look on that. Okay, so now let me make use of a diagram to explain you the concept here. So let us say this is a body which is under free fall. Let us say it starts with position O, A, then it's B, and later it is C. Okay, now you say this much was the distance traveled in T1 second, this much was the distance traveled in T2 seconds, and this much was the distance traveled in T3 seconds. Okay, so let me correspondingly mark them as H1, H2, and H3. Now, see, what is given in the question is during the first second, third second, and the first second and third second. So, it is not S, it is, which is asked here, it is Sn. So, what is Sn? I'll write it like this. Sn is the distance traveled in the nth second. All right, or second 2 is let me highlight this. So in the nth second, so Sn is the distance traveled in the nth second. Okay, in which case what is S1 is equal to? S1 is the distance traveled in the, instead of n, what do we have? The first second, so we'll write it as first second. Let me highlight this portion also. Similarly, what is S2? S2 is the distance traveled in the second. Let me highlight that also. Second. And what is S3? S3 would be the distance traveled in the third second. Okay. Now, what is S1? What is the equation for S1? See, we're not going to discuss the derivation here. Anyway, so Sn is basically u plus a by 2 into 2n minus 1. This is the equation for the Sn, right? This is the equation for Sn. Why are we not discussing derivation? Because we are doing MCQ practice here, not a lecture for the school level physics. We are purely dealing with entrance level topics, so let us not go into the derivation part. Okay, now that we have discussed Sn is equal to u plus a by 2n minus 1, let me continue the problem here by writing S1 is equal to, to make the concept clear, we rewrite the equation. Sn is equal to, what is the equation? U plus a by 2 into 2n minus 1. Now, since the body is in free fall, from rest, right? From rest, what can we say? U is equal to 0 and A is equal to G. In which case, Sn here would be equal to G by 2 into 2n minus 1. So, what is S1? S1 is equal to G by 2 into, instead of, or let me write like this. What is S1? S1 is equal to S when n is equal to 1. G into 2 into 1 minus 1, which is equal to G by 2 into, what is 2 into 1? 2. 2 minus 1 is 1. So, write it as G by 2 into 1. Similarly, what was the question asking about? First, second and third, right? Okay, so the second will be S2 is equal to, right? S2 is equal to S at n is equal to 2, which is equal to G by 2 into 2 minus 1, which is equal to G by 2 into, what is 2 into 2? 4. 4 minus 1 is 3. Okay. Similarly, what is S3 is equal to? S at, I lost, okay, first, second and third of seconds. Okay. So it is n is equal to 3, which is equal to G by 2 into 3 minus 1, which is equal to G by 2 into, what is 2 into 3? 6. What is 6 minus 1? This is 5. Now, what is that we have been asked to find out? The ratio of these distances, S1 is to S2 is to S3, which is equal to G by 2 is to G by 2 is to G by 2, and what are the remaining values? 1, 3 and 5. Now, if you remove the common ratios, what do we get? What we get is S1 is to S2 is to S3 is equal to 1 is to 3 is to 5. Now, so this is S1. Now, what is Sn? Sn is G by 2 into, so this actually proceeds like this. It goes on up till G by 2 into 2n minus 1. So, when we cancel out G by 2 from the entire ratios, what is left at the last ratio? It is 2n minus 1, which makes the final answer to be 1 is to 3 is to 5, etc. up to 2n minus 1, thus making the correct answer as option D.